Bismillahirrahmanirrahim. Let's study functions today. I'll start by asking you people, first of all, that what do you understand by the term functions? Or let me ask you an easier question, that what is the difference between a function and an equation? Yes. Who would like to explain, or if she wants to
In
tell
an
us?
equation, you solve for the value of x. In a function, you input the value of x.
Okay, very good. An equation is solved to get the value of x, while very good, very good. Okay, this is a good difference, while you put the values of x into the function. Okay, anything else?
And there's a single input of x.
Where? In equation or in the function?
Function where there's a single input of x.
Single input. Okay. Anyone else?
Sorry. मतलब single y होता है. जितने भी
Okay.
x हो उनका एक ही
Okay,
function
there
है.
is. Okay, I think I missed that. I should note it down. There are basically, yeah. Okay, I'll tell you about that. Okay, like taking the words from you people, the difference between the function and the equation is, you see that we are many a times we say that this is a quadratic function, and then we are saying that this is a quadratic equation. This is a cubic function. This is a cubic equation. Okay, this is a trigonometric function, this one is a trigonometric equation. Mainly we have the functions. Okay, now when you have for example, there is a function which is f of x, that is equal to x squared plus x, and then you have minus 12. Okay, now, when you're given that, okay, find x for f of x equal to 0, and then you make it x squared plus x minus 12, that is equal to 0. Now, this is a quadratic equation that has been taken out from this quadratic function. So, an equation is taken out from a function. Okay, and function is a very broader, a very vast kind of a term. Okay, secondly, a function cannot exist until and unless you give its oqat, you give its limits, you give its domain. That if this is a quadratic function, then for what values of x we are going to study this? For what values of x this is defined? For what values of x this is not defined? Okay, so there has to be domain with the function. Like if you, there are questions here in this book where it only says that there's a function blah blah blah, and does not mention the domain with that. So a function is nothing without a domain. Like a car is nothing without an engine. Okay, you can have a beautiful car, but if there is no engine in it, that is simply useless. Okay, so a function is basically studied on the basis of the domain given to us. Now, this domain is the values of that variable in which terms this function is existing. For example, you must have seen like there is a function g of x that is equal to 2 over x minus 1. And with this, it is written that where x is not equal to 1. Do you know what does this mean when it says x is not equal to 1? Hmm? Yes?
That when x is equal to 1, this function is not true.
Yeah. So this is basically we are indirectly given a value. Okay, yaar, you put whatever you want to put in it, but don't ever put 1 into it. For this one, your function will be undefined because 1 minus 1 is 0. So this will go on to the infinity. This will be an undefined function. Okay. So mainly today we shall be talking about that. What is you should note it down, and you can remind me if this target is not achieved by the end of this class. That what is a defined and undefined function? Okay, that is the first thing. And before that, I'll be talking about the functions notation. Okay, functions notation. Um, notation. Okay, then I have to tell you that what is a many to one function, what is a one to one function, and what is a one to many function. Okay, and if we had time, I'll try to introduce the concept of the range. Okay, so basically, we're just going to get the orientation of this topic, a huge topic, which is called the functions. Okay, so please note it down so that you can tell me one by one that what is going to be the next thing if I miss anything. Okay, now first of all, the functions notation. Um, Functions notation. You must see this, and then I'll be going into the next targets. Okay. This function f of x, now suppose there is a linear function, taking a very easy example, okay, for all real values of x, okay. This can also be written as f is a function that maps x onto x plus 2. Okay, so these both mean the same. If f of x is equal to x plus 2, then f, like I read it like this, that f maps x onto x plus 2. Okay, then there are some typical diagrams for this. For example, this is going to be for the domain and this is going to be for the range. Okay, now if x is suppose 0, 1, 2, and this is the f, okay, and through f, it is mapped onto f of x. So you have 2 here, you have 3 here, you have 4 here. So this means, like, you can see the arrows like this. So this is a typical functions diagram. That means 0 is mapped onto 2 through this function f. 1 is mapped onto 3 through this function f, and 2 is mapped onto 4 through this function f. This is exactly the same if you have this x and y. You have the equation y equal to x plus 2. When you put your x as 0, you get y as 2. When you have x1, you have this 3. When you have this 2, you have this 4. Okay, so this in this like this 0 is being mapped onto 2 is absolutely the same like a point with the coordinates 0 comma 2. This 1 is mapped onto 3 is absolutely the same as 1 comma hello, this is 1 comma 3, and then this is going to be 2 comma 4. So that is how you, like, these are the points on the graph of this function, which is f of x equal to x plus 2. Okay, so if you have this is your x-axis. Okay, so instead of f of x, you can say this is your f of x-axis. Okay, so we normally change this to keep the thing simple. We change this with the y over here. Okay, so we have the x-axis and the y-axis over here. Okay, so is it clear to you that this 0, 1, 2, now this is basically, this is also called the set of domain. This is the domain that is also the input of a function, okay? And this one is the set of range, okay? We get used to it calling this the values of y actually, okay? Or this is the output of the this function. Okay, so x is the values that you put into your function, and f of x is the result of that. Okay, now the same things 0, 2, 1, 3, they're also written like if I tell you, like you people are used to it quite clearly. You people know that f of 0 would be 0 plus 2, and that is equal to 2. F of 1, that is going to be 1 plus 2, and that is equal to 3. And then f of 3, that is going to be, sorry, there is f of 2. That is going to be 2 plus 2, and that is going to be equal to 4. Okay. Any questions so far, बच्चों? नहीं तो फिर मैं आगे जा रहा हूँ. ओके, अच्छा. Now these diagrams for, I mean, these notations or these representations of the functions, there are many ways we do that. Now there are typically three kinds of functions with us. uh, what did I write after this functions notation?
Defined and undefined form.
Okay, defined and undefined. I'll come to that. Before that, I would be telling you about this. Okay, let me. I'll keep it over here so that I can get back to this notation over here. Okay. Now the defined and undefined functions. Let me tell you about that quickly, and then we get back to the functions notation. Okay, bachcho. A function is defined. Before I tell you that what are the defined, let me write over here so that I remember this. Defined and undefined functions. Okay. Now, but so, suppose you are a very mathematical person, okay, and you are drawing a curve, maybe for, I mean, you have drawn a curve that, this is like, it's going like this is where you started. Suppose you started your A level mathematics at 80%, okay, and then it went higher. Like, these are, you have drawn a curve through the different, um, after each test you have been, I mean, marking that, okay, this is your first test, the second test, the third test, the fourth test, the fifth test. Okay. Acha. Now, there are two kinds of curves you have drawn over here. Okay, let me use a different color over here. Now, this is going to be, okay. Now, this is another graph for your performance. Okay. Now, can there be a test where you have where you can have two different kinds of marks? The test is the same, but it has two different results. Can you, like, you're given a test back and you go home and you tell your mama that, mama, I got 17 out of 20. And I also got 12 out of 20 in this test. So is this something sensible?
No.
No, obviously, one test can have only one mark. Okay. Now, for example, if I draw a vertical line over here, okay, like this, there is a vertical line over here. Now, suppose this is your test number 5, okay, and here you're getting, let's say, 20% here, you're getting 90%, and here you're getting, let's say, minus 10%. Is it possible that in the same test, you have three different kinds of results? Hmm? Can we say that in today's match, Shahid Afridi made a century? He also got out on zero. He also made 38 runs. Can we say that? Hmm?
No.
No, we can't say that. Okay. So if you're giving two different marks to your mom, so that means you're telling a lie because you forgot that that once you told the actual marks and then you're exaggerating your marks and telling a different result. Okay, so that is going to be represented here. Like suppose if I have some space over here, I want you to show it in the same way as I have drawn it here. Okay, now for this, let's say you have, like, this is the domain, this is the range here. Okay, this is x, suppose the function h, this is h of x. Okay, now suppose you have 2 and you have 3, there is 3, 4, 5. So this is the image, this is the image, and this is the image. So this one is not a defined function because this is one to many, function. Okay, this is not a defined function. because this cannot happen mathematically or realistically. Okay, for that purpose, if you want to, you must note it down. If you want to see that if a given curve is showing a defined test or not, you draw a vertical line onto that graph. Okay. If the line passes more than once through the graph, so that means the graph is not showing a defined function. Now, if you look at this upper graph over here, you can draw as many lines as you want, but no line would be passing through this curve twice because this is a defined function. Okay, so this one is a defined function and this one is not a defined function. Okay, and I should show you this. How would this be represented through this kind of diagram here? Now, suppose this is x, this is j, and this is j of x. Okay. Now, let me first explain to you and then I'll complete this diagram. Okay. So there is a vertical line test. The vertical line test is used to determine if a set is defined or undefined. Okay. If a vertical line passes more than once through your graph, it means a graph is not representing a defined function. Okay. What happens if you draw a horizontal line on a defined functions graph? For example, if I draw a horizontal line here, you see this horizontal line is passing 3 times. Now, is it possible that you have same marks in 2 or more tests? Yes or no?
Yes.
Yes,
Yes.
this is possible. Is it possible that we have the same temperature on different days of a year?
Yes.
Yes. Is it possible that Shahid Afridi has same score in different matches?
Yes.
Yes.
Yeah, many a times he got out on zero. We know that, Hannah. So if you have the same y coordinate, but there are the different x coordinates, so it would work. Like, let me show you here. Suppose you have 1, 2, 3, 4. There is A, B, and C. This one has the same image as this two has this image. This three has this image. This four has this image. So this is a defined function, okay? But this is called many to one function. Many to one function. Okay, it is defined, but it is a many to one function. So if a function is one to many, then this is going to be an undefined function. Okay, but so are you getting my point? My whatever I want to tell you, do you understand that? Can you explain?
Yes.
If someone asks you that, what is the, give us the example or any daily life example for an undefined function. Can you have the same temperature, I mean, different temperature for for a place at the same, I mean, at one time? For example, I'm sitting over here and I tell you that right now the temperature in this chemistry lab is 10 degrees. It is also 20 degrees and it is also 30 degrees. So would you believe me? Hmm?
So
Nahi na? So it has to be just one temperature. And there can be many days where this chemistry lab could have the same temperature. So that is many to one. Okay. So you cannot, your domain cannot have more than one images, but there can be, the range can have more than one, like, um, members of domain which can have that as its image. Like, if you look at this example, so you have a point 1 comma a, you have a point 2 comma a. You have seen this a lot. For example, you have recently done the graphs of the sine and the cos. Look at the sine graph. It was like this. If you keep on drawing it, so you see, if I draw a horizontal line through this, so this will be happening many times, that you will have this value of half here, here, and here. So this is a defined function, but this is also a many to one function. Okay? So guys, I have told you about the functions notation. about horizontal line test, about the vertical line test. Okay, I'm going to repeat that the vertical line, you must note it down, guys. The vertical line test is used to determine if your function is defined or not, okay? And the horizontal line test is used to determine if your function is a one-to-one function or not. Look at this the example in the middle. This is called the one-to-one function. This is the most favorite function for us in our syllabus, okay? So we would always be looking for a one-to-one function. In fact, I should draw a heart around it, okay? So we'll always be looking for this one-to-one function, okay? There are many reasons for that. You will come to that, okay? Suppose you have a graph which is like this. For example, it is like this. Um, let's say you have something like this, and you see this exponential graph here. So if you, this graph passes the vertical line test, okay? So you draw, so this is a defined test, function, and this also passes the horizontal line test, okay? No horizontal line would pass more than once through this. So this means this is a one-to-one function. Can you name a function which is very famous one-to-one function? And you know about that. Hmm?
Y is equal to X.
Yeah, the linear function. Linear function is the one which is a one-to-one function, okay? So that was it from the first part of our session, where we have discussed about the functions notation. Uh, what are the defined functions, undefined functions? What is a one-to-many function? What is a many-to-one function? And what is a one-to-one function? Okay. In the next segment, can you tell what do I have to talk about the next segment? Yes, the one who listed it down. Bacho,
The
what is,
range,
huh?
the range.
The range, okay. In fact, I'll be talking more about the domain first, and then I'll tell you about the range, okay? So let's come back for the next session. Thank you very much.